So we're going to do a little introduction to algebra, right? Notice this course is largely algebra. I'd say about 3/4 of it is algebra. So what's algebra about? Um, algebra, in this topic of algebra, you find that what we'll do, we try to model real life situations, not just real life situations, but problems in all of the sciences, I would say. And we try to model it, right? Mathematically. Now, in order to do that, what we have to do is we have to find ways of representing, properties of, things, whether be it their objects, their shapes, their whatever they are. We want to represent them with what we call variables, right? And instead of using the word variable, let me use the word a symbol, right? For example, just to give you an example, maybe you're dealing with, all right, a rectangle, and you want to model the perimeter of this rectangle. So maybe what we'll do is we call the length L, the width W, and we say the perimeter is 2 times the length plus the width. You see, so we're able to come up with a formula, right? Which is really, we can call it a model of the perimeter of the rectangle. Did I say triangle? Rectangle, right? Yeah. So that's the whole idea. Trying to represent properties, right, of things, well, whatever problem we're trying to solve. Trying to represent properties with symbols, right? And we use all kinds of symbols. That's why you see X and Y so much in algebra. It doesn't have to be X and Y, right? So you know about, okay, you have a circle. I know this doesn't look like a circle, right? And your radius is R, right? Here's a formula. A equal pi R squared, right? So this is a relationship, between the area of a circle and its radius, right? So just like this one, we try to kind of form a relationship, right, between the perimeter and the length and width of a rectangle. Right? That's what you will see in algebra. What we try to do is we try to model, right? You want to model everything mathematically. Right? When you say model, maybe you're trying to find mathematical relationships. Later on, you'll learn about functions that describes how things behave, and in doing that, well, we can write them out in words. I'm not saying that algebra doesn't have anything to do with any words at all, but largely, we're going to try to describe different characteristics of a problem that we're dealing with in terms of some symbol, right? We're seeing examples here, right? We're seeing examples here. And here is a rectangle. We give a certain characteristic, the width in this case, the letter W, right? That refers to the width. You have to write down the word width, right? The length, we say, all right, let's call it L. So there's a characteristic, right, of the rectangle. And then we try to form relationship between that and other properties of the rectangle. For example, the area of the rectangle will be what? L by W, right? Length by width. Right? So again, we come up with another relationship here, right? Where we connect the area with certain characteristics of the rectangle. And that's what algebra is about. right? And that's why you're seeing a lot of letters replacing numbers, right, in algebra. Algebra, though, besides, and you will figure that out very soon, that a lot of the things you see in algebra are not, they don't really come from real life, right? And algebra is largely about developing, people's cognitive abilities, right? Help them to think abstractly, help them to think logically, step by step, right? So instead of, if I say, man, when you talk, okay, algebra, you will hear about equations, simultaneous equations, quadratic equations, lots of it. We don't ever apply in real life, right? Nevertheless, the the study of algebra helps us to develop cognitively. They have seen that connection. And that's why no matter where you go, any university you attend, any program you do, there's some mathematics in it. And in the mathematics, there's always some algebra. And that's a simple reason, right? I know sometimes lecturers, teachers try to connect a lot of what you do in algebra with real life, but lots of times the students can see that there's very little connection, right? So at least my conception, my idea behind teaching algebra is not for you to use it in real life, but to develop your cognitive processes, right? Your ability to think logically, abstractly, right? And to solve problems. That whole step-by-step process of solving problems is what algebra is about. And when I teach algebra, I like to emphasize that rather than trying to say, you know what, this problem resembles something you'll do in real life. Oftentimes, that is not true, right? Good. So in algebra, as we said, there's that attempt to represent things with or characteristics of objects, of all kinds of things in the real world using symbols, right? Sometimes it can be numbers we are representing using symbols, right? And we try to form relationships, equations. There's something called identities. It can be a model, it can be a function, right? All these things you will try to do in algebra, right? And at the end of the day, you have to be able to manipulate. You will have to be able to manipulate what you call algebraic expressions, right? You will have to manipulate algebraic expressions, and that manipulation involves addition of algebraic expression, subtraction, multiplication, and division, right? So you will have to do these 4 operations with algebraic expression. Then a little later, you will meet what we call algebraic fractions. Algebraic fractions, right? And you have to be able to, again, manipulate those, right? You learn how to add them, how to subtract them, how to multiply them, how to divide them. And then when you finish doing all of this, when you know how to, move around algebraic expressions and so simplify them, factorize them, add them, subtract them, multiply them, divide them. When you finish doing all of that, well, then we'll make use of that knowledge now to solve equations, inequalities, right? You're going to hear about quadratic equations, right? All of those things we'll get into. Not today, of course, right? So we're going to start with very, very simple things, right? Very, very simple things. And we're going to start with what our course outline says, substituting in algebraic expression or equations, right? Whichever of the two. So how do we do this? You know, we'll start with a very simple one, right? Let's say, all right, we just use the formula just area equal pi r squared, you know, and I mentioned that um, this this relationship here, this equation, actually connects or relates the radius of a circle to the area of it, right? And so if we're given, let's say we're given pi equal 22/7 and r equal let's say 7, right? Find A, which you know is the area of the circle. So what do we do? What do we do? Well, we can substitute the value of pi and 7 here. And we get what? A would be equal to 22/7 times 7 squared, which is 7 multiplied by 7 right? Then cancel one of these 7 with one of it. And you're left with 22 multiplied by 7. Somebody do that for me. Right? And we get A equal 154. Let's not get into units and so for area right now. Right? You're just learning to substitute in an algebraic. In this case, it's an equation, right? It's an equation. There's a relationship that we have. Everybody get this? Simple enough? Huh?
Yes, sir.
Yeah, this is simple enough? All right. Let's go to something hard. Let's go to something hard.
Sorry, question.
Yeah.
For the part that you put 7 multiplied by 7, how come you get to multiply this 7 by 7? Is it because of the 22/7 we put it back there? The 7 up there?
So the formula has r squared. R squared means r multiplied by r. R squared means r multiplied by r. So if r equals 7, you know, right, 7 by 7.
Oh, okay. I understand.
Yeah.
Thank you.
Good. Let's take a hard one. Let's take a hard. Okay, let's say, all right. Um, if ax squared plus bx plus c equals 0, then x equals minus b plus or minus the root of b squared minus 4ac all over 2a, right? Okay. Overshoot the thing. Yeah. Good. So let's say you have this now, right? You give me, you told that if you have an equation of the form ax squared plus bx plus c equals 0, then x is given by this formula here, right? Later on, you'll come to find out that this here is actually the formula for solving what we call a quadratic equation. We'll get there. But I'm just showing you how to do substitution. So let's say you're told solve the equation x squared plus 5x plus 6 equals 0. You're told to solve that. Well, basically what you want is the value of x. So x then will be equal to, you got to watch now, what is b in this equation? It's 5, right? So you start with minus 5 plus or minus the root of 5 squared minus 4 times what's a? A is the one in front here, the number in front of x squared, right? A is the number in front of x squared. So in front of x squared here is 1. Multiply by c. What's c? C is the number at the end here. What's the number at the end here? 6. All over 2 times a, which is again, a is the number in front of x squared. What's the number in front of x squared? It's 1. And now we have to simplify that. Well, so how do we do that? So let's see how we can simplify that. So this is going to be, all right, minus 5 plus or minus. What does all of this turn out to be? 5 squared is 25 minus 24. So that's root 1 over 2, right? Which is equal to minus 5 plus or minus 1. The square root of 1 is 1 over 2, right? So this now, x is equals to, sorry, use the word either. X is equals to minus 5 minus 1 over 2, which is minus 6 over 2, which is minus 3. Or x is equals to minus 5 plus 1 over 2, which is minus 4 over 2, equal to minus 2. Right, so those are your two values of x. So this is a harder example of substitution, right? Very hard example. In the notes I sent you, there are several other examples. Yes, somebody raising their hand there? Yeah.
Sir,
Go
how is
ahead.
it you get root 1? If it's 5 and it have a power at the top there, it is supposed to be 5 5 is 25, and then you're gonna multiply the 1 and the 6.
You don't see a 4 here? You don't see a 4 here? 4 multiplied by 1 by 6, not 24.
6. Yeah,
So 25 minus 24 now what?
okay.
Right? And then you do the subtraction. You do the powers of, remember that? Powers of, you see, you can't forget what we did last week, the other week. Powers of, so I squared the 5. And then you do multiplication. 4 by 1 by 6 is 24. So 25 minus 24 is 1. Right? Get it?
Yes, sir.
Good. A harder example. Right? This is a harder example. We will do a lot more of this a little later on. But I just want to awaken you, you know, to expressions and how to substitute in an expression, right? For more examples, if you check the notes, you'll see a whole lot of examples, right? Take some time to go through them, right? And see if you can make sense of them, right? So let's go to a little bit of addition. Addition of algebraic. This is supposed to be an AI expression. Right? So when it comes to addition, let me just give you a typical example. Right? So let's say you have, all right, 7x plus 2y plus 4x minus 3y. Let's say you have some, and you're asked to simplify it. simplified summary, right? So here, well, I should add in subtraction here one time. Subtraction, right? Addition and subtraction. Addition and subtraction, right? I'll put the two together. So here you have what we call term. This is a term, that's a term, that's a term, that's a term. So the expression is made up of a number of terms, right? And some of the terms involve x, some involve y. So when it comes to addition, you can't just add 7x and 2y and maybe say 9xy. No. You have to add terms that are similar, right? They have to be similar. And by similar, you mean, okay, the x's you can add, and the y's you can add, right? Or subtract, whatever the case might be. So in this case, some people do this. They rearrange the expression and put the like terms together. You don't have to. As you get good with this kind of thing, you could watch this thing and write down the answer. But I'm just doing it for, you're a starter, So now that the x's are together, we can now add the x's. So you get, what's that, 11x. And here you have the y. You have 2y minus 3y, which will give you minus 1. Right? So you add and you subtract like terms. Together?
Yes, sir.
Good. Let's do one that might be a little more complicated. I don't know why this thing is doing this. Can I refresh or something? When I do this, it keeps. For whatever reason, I don't know why this whiteboard is doing it. Let me pause the video a little bit. See if I can get another whiteboard. Yeah, good. Let me show you another one. Let's take one. This one might borrowing from our note. Simplify. Something like 15x squared minus 7y squared plus 9y squared minus 8x squared. Right? So yes, you can have expressions with the unknown is raised to some power. Right? You can have that too. What you're looking for though is the terms that are similar. Right? That's what you're looking for. So here you're seeing an x squared term. There's one here. These are not x squared term, they're y squared term, right? So if you want, you can do this. You can group them up together like this. Right? Right? Don't be fooled by whatever they put. Yeah. And now you can simplify this piece and this piece, right? So 15x squared minus 8x squared will give us what? 7x squared. And minus 7y squared plus 9y squared will be plus 2y squared. Right? You think you got in the knack of it?
Yes, sir.
Good. I wonder why this thing is left here. It's not erasing, it's not strange. Let me see something. If I move it up, it's not moving at all. All right. Yeah. So that's your little bit on addition and subtraction there. Again, there are lots of examples in the notes, right? I I could demonstrate from now to tomorrow in examples. But the mathematics, again, as I said, your cognitive processing will not develop unless you look at these examples and you internalize. You internalize what's going on here. What is the author or the teacher really doing when they're, grouping like terms, subtracting, what is acceptable, what is not acceptable. You have to figure that out, right? And when you figure that out and internalize it, well, you grow mentally, right? You grow mentally, and then is when you understand it. And they can get even more complicated. Let me borrow one that involves even more Tor. I'll borrow one from again the note. Let's say you have to simplify. Right? Don't mind my handwriting. But this one looks horrible, right? But you don't have to be worried about nothing, right? I can write one that fills the whole computer screen, but you do the basic. Look for like terms, and you perform the arithmetic on the like term. Yeah, yes, Howard.
Yes, sir. So in this equation here, like where you put a square, we're not saying like 50 multiplied by 50. We just minus in and just put back y square or x square.
Wait, you're talking about the last one.
Yes. You had 15x squared minus 8x squared. So what I was trying to say, if you're just leaving it, just minusing without putting like 15 multiplied by 15, then you put the answer, but it's 15 multiplied by 15 my x, and then you put back the minus sign and put 8 multiplied by 8, and then
No.
find the answer.
Let me just highlight something. This doesn't mean 15 multiplied by 15, it means 15 multiplied by x multiplied by x. It's the x that is squared, right? The number in front is not squared, it's the x that is squared, right? The x represents something. 15 is
okay.
not squared, right? The 15 is not squared.
Okay, sir. Thank you.
Yeah, and remember you're doing subtraction here. You're not multiplying anything. You're doing subtraction. Right?
Yeah, yes, sir. Thank you.
It's understandable if when you see it before, it's puzzling you, and so that's understandable. Right? But the only way you can get this, as I said, you will have to expose yourself to more examples. And no matter how much examples I show you, you see in the textbook, right? You will not get it unless you take your hand, right? You take your hand and you get a piece of paper and you try a few and see whether you get it right. Right? That's very important. Right? Good for you to try it with your own hand. If you don't do it, you know you can think you can look at the examples and read the notes and watch the video and say, man, I've been over the video 5 times. I read the notes 5 times. And when I give you a problem, you can't do it. Right? You have to try the thing, right? And I know I haven't supplied you answers. Basically, these notes come from what is the name of the book? Mathematics, a Complete Course by Raymond Tulsi. This is the volume 1. That's where the notes came from. And if you're not certain of your answer, you type, if you know what you're doing, you will be certain of your answer. If you don't know, and you say, man, look, where am I search for the answer? You just go on the internet, you use an AI, and you type in the thing and say, simplify it. And the thing will tell you the right answer. And you will check yours and say, oh, yes, I got the right thing. Right? And that's responsible use of AI if you want to check your answer. Right? So while we wouldn't allow you to do it in a test, when you're at home and you're studying the subject, you can use AI how much you want. It's a good tutor. it probably will do a better job than me, right? I just want to show you something. Let me just stop and show you something. I'll come back to this one, John. I want to stop sharing this screen. And I want to go to, look here. 1 second, I just want to show you them. 1 second. So here am I, right? I had a class, I don't know if you're seeing it. So I had a class where I had to prove that the limit of sec theta as theta tends to 0 equal 1, right? And I wanted a simple proof, not the one in the textbook that I have was too complicated. So I asked this AI, and this AI is, I think it belongs to ChatGPT. They have a math solver, right? So here the AI presented the proof, all well and good. But what was a big surprise to me, it has this button here that says create video. And I said, what craziness is this? And guess what? The AI created a video explaining. Let me just play it and play it for you.
Welcome to this video where we prove fundamental limit in calculus. The limit of secant theta as theta approaches
Are you hearing
0
that?
equals 1. To begin, let's recall what secant
Yes, sir.
theta is. Secant theta is defined as 1 divided by cosine theta. Before diving into the proof, let's visualize what secant theta means geometrically. When theta
Good. So what I'm trying to illustrate here is that, okay, the people solve the problem for you and then ask you if you want a video of it. Could I do a better drawing than this? You know, and speak clearer than that woman who is speaking. I mean, it's an AI voice. Yeah? I'm just showing you how you can use AI to your advantage. You understand? You can use it responsibly and you can teach yourself anything. You just get an AI to teach you, right? But no matter how much the AI do, how much examples it does for you, how much video it produces for you, if you don't study the thing and internalize what is being taught, you're not gonna get it. When I give you the test, you're gonna have a very difficult time. You understand? So while there's the AI that is there to help you, you can use it as a tutor. There's no substitute for you for learning the material, right? Practicing the material so that you get a knack of what you're learning, right? So keep that in mind. Let me go back to problem I will do. Good. So again, don't be fooled or don't be scared by you have X here, you got Y, you got Z. You know, no, you don't worry about that. You just do what I told you.
Excuse me, sir.
Yeah,
Excuse me, sir.
yeah.
Good night. So this equation that you're doing, you
Let me tell you something. It's not an equation. There's no equal sign anyway. This is an expression.
pardon?
Yeah, it's an expression. Good.
Okay, the expression, sorry,
Yeah.
that you're doing, right? Does the algebra rule apply to this?
You're talking about the BODMAP?
No, whereby you know the algebra rules. Like if you add in, like how we doing addition and subtraction, you know they have rules apply to if you add in two, a negative and a positive, or you add in a positive and a positive, the answer would be like stuff like the rule like that.
Yeah,
Does it apply to this expression?
yeah, sure.
Okay.
That's a good observation. Yeah. Right? Because the X and Y are numbers anyway. So that's what we're doing, right? So as I said, you arrange the like terms together if you want. 9x, you bring the minus 4x here. Right? No change of sign because there's no equal sign. You're not moving anything over an equal sign. Right? You're just rearranging the order here. You know, you want to bring them closer. Right? Then, okay, there's a 3y there, and then there is an 8y here. There's a minus 5z here, and there's a 12z there. Good. Now that we have gotten the like terms closer to one another, well, we can now simplify this piece. 9x minus 4x is 5x, right? 5x. 3y and 8y will give us 11y. And minus 5z plus 12z will give us plus 7z. And that's your answer there. Right? So yes, the rules are that those rules apply. Good. So now that we have dealt with addition, subtraction, let's deal with multiplication and division. All right, let's deal with those two. Going back to, all right. Good. The beautiful thing about multiplication and division is that if you have, let's say, all right, let's borrow a few from the examples in the book. Let's say you have to simplify somewhere. Simplify this here. Now, when it comes to multiplication and division, you could multiply any term by any term. So they don't have to be alike before you can multiply them. You get that? They don't have to be alike. So you can actually multiply 3 by 5, 15, x by y, xy. You could do that. Is this easier? Isn't this quicker to catch? Addition or subtraction, you couldn't add different terms that are, what do we say, unlike, right, or different. But in this case, you can multiply them. There's no harm whatsoever, right? If you have, okay, let's just go with half p multiplied by 8q. You don't have to worry, right? You can cancel the half here, 1 by, 2 into 2, 1, 2 into 8, 4, you can do that, right? And you have 4pq, right? If you want to do that, you can multiply half by 8 is 4, p by q is pq, right? You can do that, right? And my friend just don't talk about negative and positive, and so yeah, you can have all of that if you have, okay, 5y multiplied by negative 3y, right? Positive by a negative gives you a negative, so that's minus 15. Y, all right, y by y you get y squared, you know? The rules do apply. The rules from arithmetic, yes, they apply. Let's do a couple more that involve division in particular. Now those might be a little troublesome.
Excuse me, sir. Can you please pull back to the one before this one, the equation before this one?
Okay. The expression.
Yeah, please.
This one?
Yeah, expression.
Yeah.
Yes, with half p. Can you please go over it for me?
All right. So you can write it. Let me write it. Half p times a q. So you can multiply this number by that number. A half by 8 is 4. Right? Half
Yes.
by 8 is 4. P by q is pq. Not p plus pq. Remember you're multiplying. This is like, okay, let me write this out. So that you slow me up. Let me write this out. This is like, okay, it's half multiplied by P multiplied by 8 multiplied by Q. Right? It's another way
Yes.
of writing it. If you want to put, like, okay, the like terms, like the whole numbers there, sorry, not the whole numbers, the pure numbers, you put, okay, half by 8 multiplied by P multiplied by Q. You can do that too. Half by 8 is 4. P by Q, right? PQ. You don't drop out all the multiplication signs.
Okay.
Right? You like it that way? If you think you like that, no problem. But as you develop proficiency, right? As you develop
Yes.
Sorry, so all of them is for the same. All equations work out the same.
all expressions when you're simplifying, when you're multiplying and dividing, yeah. Right? You don't have to worry that they have to be like
Okay.
before you can multiply them. P and Q are not alike, but you can multiply them. Right?
Yeah.
Like people, you call it a matter. Anybody can make any children with anybody. I mean male and female, right? X squared y. Okay, let's take this one. This one look rather complicated. 3xy squared. Good. So you can do this different ways. I probably do more than one way. You can do this. You can take this and you can write it like this. 50 times, okay, x squared, you can write it as x multiplied by x times y cubed means y multiplied by y multiplied by y multiplied by z. And you're dividing by this, right? So 3 times x times y, right? So you can do that, and then you can cancel what can cancel, right? 3, 1, 3, 5, okay? This x, so, and that x there, There are no more x's here, but there, okay, there's a y here, and there's a y there. There's a y here, and then there's another y there. What's left? Right? Ignore this thing here, man. I don't know what to do about it. So we'll have 5 times, okay, x times y times z. So 5 times x times y times z, right? And everything at the bottom cancels, right? That's what you get.
Sorry, could please go over that one?
So first, this is just one way, right? When you learn a little more algebra, you learn a quicker way. And I'll show you this, right? When you learn what you call indices, right? You'll see another way to do it. So what we do, I took this here and I expanded it out right out, right? So 15, well, this means 15 multiplied by x squared, which means x by x, times y cubed, which means y by y by y, times z, right? So that's what I did. I expanded the whole thing. So this is divide. So I put this underneath it, right? Dividing. This line means to divide, right? So 3x, so that's 3 times x times y squared, which is y by y. And then you cancel as much as you can. Right? In this case, all that was at the bottom cancel with something on top, right? As you see here. The 3 cancels with the 15, you get 5. This x cancels with that x, so you get 1 and 1. This y, well, there are no more x up here, right? So you go to the y. This y cancels with that y. This y cancels with that y, right? So we're left with this 5, this x, this y, and this z. So we just multiply all of it.
So,
5
sir,
x by y.
if all of them in cancel from the bottom and end up with division over here, you still have to go on with it.
All right. If you end up with something at the bottom here, let me do one like that. Let me do one. So let me go with the C, right? let's say you have, let's say you have 15x, what was it? X squared, is it x squared? X
15x
squared
squared, yes.
cube z divided by, and let's go with 2, right? Let's go with 2. 2xy squared, right? So what will happen? 15 can cancel with the 2, right? I think I'll come to this one. Y by y by y, like I said, right? This is a set. I'll put a stroke through it. 2 times x times y by y, right? So you can divide this, right? So you leave it like that. So this x and that x is canceled. This y and that y, this y and that y, right? So you will end up with 15, what is it? X, y, z, all over 2. Right? You can write it like that, or you can write it like this. You can write 15 over 2 x, y, z. You can write it.
Okay, thank you.
Alternatively, when we do indices, right? Let me just show you this little bit. When we do indices, you will see that there's a shortcut where you don't have to write out this thing like this. You will just do this. Let me go back. Let's say this was the 3 here, right? 3. So, okay, 15 divided by 3 is 5, all right? X squared divided by x, because the power here is 1, right? 1. You subtract the power. So x squared divided by x, you subtract the power. 2 minus 1, you get x to the 1 power, which is x. Y cubed divided by y squared, you subtract the power. So y cubed, and you take away 2 from 3, you end up with y to the 1 power. So you end up with y. And then z divided by, well, there's no z here. You put back the z here, right? You will learn this shortcut a little later on when we do indices. Don't worry yourself. Right? Don't worry yourself. I know when you look at it, it might look hard, right? But we'll come to that a little later. Good. A very important law now. So we dealt with a little bit of addition. We dealt with a little bit of subtraction. We dealt with a little bit of multiplication, division. There's another one that is very, very important. There's something called the distributive law, right? The distributive law. And this law is very, very important because it will help you to do 2 things. Right? Let me give you the distributive law in very easily. So sometimes you see it like this, right? A plus B. All right. I use the same thing that is in the textbook, so you don't see something different there, and you'll ask me, man, sorry, why you use differently. So okay, if I have this, I don't like it written like this, right? I like it written like this, where the x is in front. Right? What you do, you multiply what is in front of the bracket or outside of the bracket, whether back or front, by everything inside. It's equal to ax plus bx. Right? I like this form. I like this form, this PC. You do see this sometimes, right? So this is basically the distributive law. It's as though you distribute this x, each of these things in here, right? You multiply the x by everything in the bracket, right? It works with a minus sign in here too. You have x, and you have a minus b in the bracket. It's equals to ax minus bx. Nothing wrong with you putting xa and xb too. You can write that. That's okay. But we just, because we know a come before x in the alphabet, it sounds better, right? Doesn't it? It sounds better. And that's why you write AX minus BX. So this forward expansion is very useful. You'll see it later on when we solve equations, when we have to simplify stuff and so on, right? But this backward motion, when we take this and get this, right, is very important for something called factorization. And we'll get to that. I think we'll do that. I'm not sure we can do that tonight. I'll see how far we can go, right? I'll see how far we can. So the distributive law is very, very important, right? In removing a bracket, maybe because you want to simplify something, right? Or to factorize something, right? We use it in both ways. So later on, you'll see how important it is, right? So let me give you some examples. Give you some examples. Like how the distributive law is used to remove a bracket, and then you'll see how we can use it to factorize stuff, right? We'll do a whole topic on factorization. For now, we'll look at using the distributive law to remove a bracket. Maybe you want to simplify something. So look at something. So let's say you have 3 times x plus y plus 5 times x plus y, right? And you're asked to simplify it, right? I want to simplify it. So we just said the distributive law basically is that you multiply what is in front here by everything in it. You multiply what is in front here by everything, right? So we multiply 3 by x, you get 3x, plus 3 by y, you get 3y. Come over here now, positive 5 by x, you get positive 5x, right? Positive 5 by positive y, you get 5y, right? And now if you want to group up the terms together, the similar terms, you can do that, put the x's together, right? And you put the y's together. Add these two, and you add those two, you get 8x plus 8y. Right? So you can use the distributive law to expand things, and it's able to, you're able to simplify. You could take this now. You could take this and factorize it. Somebody can say, factorize. I can ask you, factorize 8x plus 8y. What do? You look for the highest common factor here, which is 8. Put it to the front, and you put the x plus y in the bracket. It's like you divide each term. 8x divided by 8 will give you x, plus 8y divided by 8 will give you y. So you write it there, you factorize it. Right? So the distributive law can help you to expand things as well as to factorize things. Right? I mean algebraic expression. Expand and simplify things, right? As well as to factorize algebraic expression. Let me do one more that is a little more tricky because it will involve some minus signs and so. So look at this. Want to simplify. Yes, Shivan.
Sir,
Yeah.
the distribution law that you gave us,
Distributive law.
yeah, sorry.
Ah.
The paper or the thing that you upload on Moodle, this is not how it's showing it. Or unless.
Yeah, that's the same thing. That's the same thing. All right, let me go back.
Oh, well, now you're doing the bracket.
Here, okay.
It
You
is
down to
showing me
this
something
example?
different.
Oh, you watch it, man. That's the exact thing I write there. A plus B with x at the back is equal
No,
to
not that.
huh?
Speaking about the sums,
Uh-huh.
it is showing when you have the number outside of the bracket, the number outside of the bracket, I have to multiply everything in the bracket.
Yeah. Isn't that what it is? Yeah. That's what it means, yeah. You multiply what is outside here by everything in here. That's what you see here. You multiply this 5 by everything in here. That's what you see here. That's all. 5 multiplied by x gives you 5x. 5 multiplied by y gives you 5y. What's confusing?
Okay, sir.
So this one involves some minus signs, right? So that's why I want to highlight. Good. Good. Look at this one. So we are multiplying the 8 by everything in here, right? So 8 by 5 is 140. X, all right. 8 by minus 2y is minus 16y. Okay. Minus 3 by 4x, so supposed to be 12, minus 12x. Minus 3 by minus 3y. Somebody was asking if the rules apply. A negative by a negative gives you a positive, right? Yeah, that portion is right. Good. And now we can simplify, right? So we put the x's together, so 40x minus 12x, right? And then minus 16y plus 9y. This turns out to be what? 28x. And this will be what? Minus 16. I don't know what makes 16. 7. Minus 7y. Follow this one? So you got to be careful with your signs, right? When you're removing a bracket, this is a minus 3 here. So this minus 3 times this minus 3 will become positive 9y, right? So one of my friends, I can't remember who was the person, was asking if those rules that we learn in arithmetic apply, right? Howard, was it you? Howard?
No, sorry, it wasn't me. Sorry for that. What my question, what I want to ask, will we be able to use yes or no?
If what?
Will we be able to use calculator in the exam?
Yeah. You can use a calculator. That's not a problem.
Okay, thank you.
Yeah. Right? So everybody follow this one?
Yes,
Yes,
sir.
sir.
Good. So you will need this ability to remove brackets, and so when it comes to plenty other things in the algebra code, you will see, right? You know, it's like lots of things you learn in the lower level of school, and you want to know, what am I going to do with this? You know, but very often, right? You see that when it comes into use, right? It comes into use. All right. So I noticed in the course outline, there's something they say operations with numbers. I think the person meant binary operation. I think whoever typed course, uh, the course outline, they really mean that, right? And again, I think this is high school, right? In that you can have operations that you have to do on two numbers or more. Doesn't have to be two numbers. On a set of numbers can be defined, right? For example, and this is a nice one in the notes again. The binary between x and y, that's what you say, right? Is equal to 2x plus 3y. Right? So you are defining what you should do with X and Y, right? You are defining what you should do with X and Y. I know you might want to know what are you going to do with it. But I want to tell you this, that for those who will venture into computer science, right? You will see that this kind of thing is very useful in programming, where you define what you should do with two numbers, right? And whenever the program sees, okay, X asterisk Y, the program will do what you say it must do. Multiply X by 2, multiply Y by 3, and then add them together, right? So it's like something you will do in programming, but forget it. When you get there, you get there. If you ever get there, right? A lot of people are shunning away from computer science these days, right? They feel AI will take over all their jobs. So if this is how the operation between X and Y is defined, the binary, right? The binary operation between X and Y is defined like this. Well, then, what will be the value of, right? If you have to evaluate 4 asterisk 5. And what do? You simply substitute, and here's where substitution comes in again. 4, you substitute in place of X here. So 2 times 4, so write it like that. If you want to put the multiplication sign, it's up to you. Plus 3 times 5. If you want to put the multiplication sign, it's up to you. Right? And that'll be what? 8 plus 15, which is what? 23. Right? Follow this one? So if the binary between X and Y is defined by 2X plus 3Y, so if X is 4 and Y is 5, you simply put 4 in the place of X and 5 in the place of Y. Over here, right? Over here. Yes, Born.
Yes, good night, sir. In binary equation, does X always count as 2? Or they must give you a number to put through?
They will give you the definition. They will give you the definition.
Oh, this is just an example you give me
Yes,
as 2X
yes,
plus 1.
Yes.
Okay,
yes,
thank you.
Yes. Right? You can define the binary between any two numbers. It doesn't have to be X and Y. It can be P and Q. And it can be all kinds of things you can define. Right? They have a harder one in the notes there. Let me do that one. Erase this one. So they say to evaluate 4 asterisk 5 asterisk 6. Right? So what do you do here? Well, you don't have to worry that, wait, this thing doesn't look like that. You do it in pieces. You do 4 asterisk 5 fourths, right? So you start saying, okay, fourth, if you want to write a statement, evaluate 4 asterisk 5, right? And we already found that to be 23, right? I'm going to skip that part. So this piece here, 4 asterisk 5, is 23. So now this becomes equal to 23 asterisk 6, right? Because 4 asterisk 5 is 23. We don't evaluate that. So now we're replacing this with the 23 and we get it. So this now will be equal to 2 times 23 plus 3 times 6. And somebody help me evaluate that. What number will it be? I think they got 64. Right? Do you follow this one?
Yes, sir.
Yeah. Right? So it can get complicated like that. It can get complicated like that. I think the other one is, I probably wouldn't do this. I'll just show you. The other one in the textbook has this. 3 asterisk 4 asterisk 5, right? So what you do, you evaluate, remember you do the brackets first, right? Somebody said that you're going with that rule, the arithmetic rule. So this we evaluate to be 23 already. So this is equal to 3 asterisk 23, right? Which, if you were to substitute in here again, will be equal to 2 times 3 plus 3 times 23, which turns out to be, I think they did it in the textbook, how much is it? 75 is the answer. 75 is it. 75. And of course, they can get more complicated, right? They can get more complicated. It doesn't always have to be that nice 2x plus 3y. Can I move this? Let me probably do the other example we have there. They have a horrible one there. Or really and truly, this is how you read it. So you don't have to know all these symbols. There's a little circle there, right? You can say the binary, right? The binary of A and B, right? The binary of A and B is equal to quarter the square root of A squared minus B squared, right? So you can have something as horrible as that. The binary between A and B, or the binary of A and B, is defined by this. Quarter the square root of A squared minus B squared. And then they ask evaluate. Right? So given that, okay, let's say given that the binary of A and B is this. Evaluate 5, the binary of 5 and 3. Right? That'll be equal to a quarter of 5 squared minus 3 squared, which will give you what? 25 minus, okay. Oh,
Sorry, you have off.
Yeah. I'm dropping to sleep here. Square root of 9, I think, which is a quarter times 3, which is 3/4. Right?
Sir, can you please go for that equation?
Okay, yeah. So the binary between these two numbers. Yeah, yes, Born. Let me hear your question too.
Sir, I would like to know you're getting 9 there.
25 minus oh gosh. Yeah, you're right, Joel. I'm feeling dropsy right now. Yeah,
That's why I
right.
have to repeat
Yeah.
it.
It's supposed to be 16 here.
That's an old duty. The duties will come back.
Yeah, this is supposed to be 16. Yeah. 25 minus 9 is 16, right? Yeah. So this is going to be 4. Yeah. Somebody is awake.
Yes.
Right? So, yeah, so the answer is going to be 1, right? Quarter by 4 is 1, yeah. Thank you for highlighting that. Yeah. I was puzzling you, a guy that asked me.
Yes, sir.
Yeah. Sorry about that. Something I was dropping. Yeah, 25 minus 9 is 16, yeah. Good. So, Y'all want us to take a short break and then we come back and tackle factorization?
Yes, sir.
All right. So let's take 15 minutes, will do? Or that's too long?
Yes,
Take
sir.
10 minutes? Take 10 minutes.
15, that's okay.
15, all right. Come back at 7, right? Take a short break and then we finish up with some factorization. So, with a little time we have left, I'm going to introduce factorization, a little bit of it. Another day we'll revisit factorization and deal with the factorization of what we call quadratics, but we're not going to get into that tonight, right? We'll need that for a later type of equation and so on, right? I'll introduce the idea of factorization tonight, right? So we did talk about the distributive law, right? I was going to, yeah. That's a Z, right? Yeah. So we did talk about the distributive law that if you were to have x and you have a plus b here, x times a plus b is equal to ax plus bx, right? And I did mention that while very often you use it to expand the bracket and get this, when it comes to factorization, and we should understand what we mean by factorization already, right? Like, okay, remember we talked about prime factorization when we were doing LCM and HCF? Like if you have the number 6, factorizing 6, you write it as 2 by 3, right? So you've written it as a product of its factors. In this case, it's prime factors, right? Well, that's what we're talking about here. We're not taking this and working to get that. No. We're taking this, ax plus bx. And what we're looking for, we're looking for the common factor. Pull it to the front, the common factor here being x, times. So you divide ax by x, you get a. Put the plus sign back. Bx divided by the x in front here is b. And that's what you get, right? So this is what we're going to do. We're going to take this here and we're going to write it as a product of its factors, because what you see happening here, x multiplies a plus b, right? So x is a factor of this expression and a plus b is a factor of the expression, right? So you write it as a product of its factors. That's what factorization is about. Taking an expression and writing it as a product of its factors. And throughout all of this, we're going to use the distributive law, right? We're going to use the distributive law. I'll do a couple of examples, simple, going on to some very complex ones, right? So let's see some examples. Very, very simple ones. Let's say you have to factorize okay, let me use 25x minus 10. Right? What's the common factor there? And we're looking for the highest common factor, right? That's what we're looking for. What's the highest common factor of 25x and 10?
5, sir.
5.
5, correct, right? So 25x divided by 5 will give us 5x. Minus sign back here. 10 divided by 5 gives you 2. And that's it. Right?
It's simple, sir.
Simple, right? It wouldn't always remain like that, right? It will get complicated.
Okay, sir.
All right, look at another one. Let's go with factorize okay, they have 64a squared minus 8a. That should seem to be the highest common factor of both of these. What's the highest common factor of 64a squared and 8a? Shouldn't be hard. What expression can go into both of them? 64a squared and 8a.
8, sir.
Sir.
What about the a? Can a not go into both of these, a squared and a?
Yes, sir.
Good. So 8a is the highest common factor, right? So 64a squared divided by 8a will be 8a, right? Because you multiply, then you get back that. Minus 8a divided by 8a gives you 1. And that's it. Get it?
Yes, sir.
Yes,
Tell
sir.
me, tell me if you're
Yes,
puzzled by
sir.
anything. Let's do another one. Let's go with factorizing. Factorize. They have here, all right, let me use this one. Minus 49p squared plus 7p. Right? There are more than one way you can do this. I don't like writing anything like this. I like to write this like this. 7p minus 49p squared. Right? And you're seeing that 7p seems to be the common factor, right? So put 7p outside. 7p divided by 7p is 1. Back your minus sign. 49p squared divided by 7p will be 7p. And, right? The textbook did it differently, right? And you go to the text, you say, sorry, you got a different thing. I choose to do it because it looks nicer. Mine look nicer than the textbook. You can go and check it out.
Sir, this is called factorize algebra.
What is it you say again?
Factorize algebra.
Factorization is just a little, subtopic in algebra. It's
Okay, thank you.
yeah. Look at another one. So you have to factorize 5wx plus 10w y minus 15wz. What seem to be common factors throughout here? The highest common factor.
5.
Look at it. 5 alone? You're not seeing something else common?
5w.
5w, yes, right? So 5wx divided by 5w will be x, right? Plus 10wy divided by 5w will give you y. Back that minus. 15wz divided by 5w will give you 3z, right? See that?
Then I'm 2.
2. 15 divided by 5 is 2.
No, 5
5
divided by 10, 2.
Oh my, yeah. Oh, I think I gotta be sleepy or something.
Sir, I believe you.
No, listen to what I usually do in my class at UG here. When I make a mistake and the students correct me here, I say, I just checking to see if you are paying attention. I should have used that line earlier.
Sir, I like something not knowing I do the wrong thing.
Yeah. Yeah. So I'm checking y'all are awake and following me. Very good observation, though. All right, good. So let's take another one. This one involves some grouping now, factorizing by grouping, right? And this one is going to be very useful later on. You will see, right? So let's take a few of them. Let's say, okay, you have px plus py plus qx plus qy, right? So you're noticing a lot of similarities, right? You're seeing two p's, you're seeing two q's, right? So what you could do here, you could pair these p's together, right? Some people do this. Px plus py, they group them together, plus qx plus qy, right? So they look now for the common factor, p being the common factor. So you get x plus y there, plus here, q being the common factor. You bring that to the front, end up with x plus y. But you don't stop there. You apply the distributive law a second time. Because remember, if you have two expressions and there is a common factor in them, you can pull it to the front. Right? Remember that thing? If you have ax plus bx, you pull the x to the front. Isn't that so? A plus b, isn't that what you used to do? So here we have x plus y is common. So we can pull that to the front. See? Pull that to the front and put p plus q in the other bracket.
Yeah.
Right? So it's just a further application of the distributive law. Think you get it?
Yes, sir.
Good.
Yes, sir.
All right, let's try another one. Now let's do one that maybe involves some negatives and so. Factorize 3ax for this one. So again, you see a here common. Down here you see b here common. So you can choose to go that way. You can pair these, right? And then you can pair these two, and let's see what happens. So here, the highest common factor is 3a. So we end up with x minus y, okay? Down here, common factor being b. Sorry, down here is supposed to be 2y. So I didn't see that one. And you end up with x minus 2y, right? Again, you apply the distributive law and you see this here being common. So you put it to the front. X minus 2y times 3a plus b.
Excuse me, sir.
Uh-huh.
Is it okay to put 3a plus b, then the x minus 2y, or you gotta put it
No, it doesn't
like how you
matter.
put
You
it?
can do that. You can
Okay,
do that.
because I did it
Just,
that way.
yeah, just like 2 multiplied by 3 is the same as 3 multiplied by 2. You can write it
Please
anyway.
go over back this one.
Because I did it that way. While you was writing the equation, I did it.
Okay, yeah, nothing wrong with that. Yes. So we choose to group these two together and these two together, right? So that's how we did it. All we did was insert a bracket there and there, right? And insert a bracket there and there, right? You look for the highest common factor, which is 3a, right? 3a can divide this expression and this expression, So 3ax divided by 3a will give you x, right? Bring back the minus sign there. 6ay divided by 3a will give you 2y, right? You can multiply back and see if you get that too, right? And then over here, the common factor is just b. You bring it to the front. Bx divided by b gives you b. Put back your minus sign. 2by divided by b gives you minus 2y. Now that you see a common factor here, this bracket and this bracket is the same thing. So we apply the distributive law another time now. Right? Because these two factors are the same, we pull them to the front and we put this and this in another bracket. One of the girls said you don't have to put x minus 2y in front, that can go behind. That's not a problem. You can have 3a plus b in one bracket, and at the back, put x minus 2y. That's no problem. Clear?
Yes, sir.
Good. All right. I'll do a final example. And this one is a little tricky, right? In the way the minus signs are arranged, very tricky. So you have to factorize what's mx plus nx minus my minus ny, right? Good. Now, I'm seeing, okay, x together here, okay, and y together here. Now we can group them up, right? So we go with mx plus nx, put that in one bracket. However, down here, because of this minus sign, if you put minus there and you open a bracket and put my, you cannot put minus here. You have to put a plus there. Why? Because if you were to remove the bracket, then you will get back your minus. But if you have a minus here, this minus and this minus will become a plus. But here you have a minus, you see? So you have to change the sign here. You see that trick? See that trick? You have to change the sign if you put the minus out here. Is that clear? It's as though you actually factorize out -1 out of the bracket here. Right? I'll show you a way that you can avoid this in just a moment. Right? Good. So let's proceed. So we have to do that change of sign there. So now our common factor here is x, so you get m plus n. And our common factor there is y, so you get m plus n. M plus n is common, so you put that in one bracket, times x minus y. Right? So the only trick here, or the only difficult thing, is knowing that if you were to put a bracket around these two here, you have to change this sign. Right? To avoid that, let's say, man, you say, you know what? You know, this thing, before I make a mistake with this sign, I want to do the approach. Right? So here what you can do. What you can do is go this way. Put the m's together, watch. Take mx plus, sorry, not plus. Go with mx. Take this mx and this, you see, is minus my here. Good. So you go to m's together. Plus nx minus ny. Right? And now you can safely group them together because there's a plus sign here. You don't have to worry. Now, let me move this thing a little. Yeah. ny, right? Good. So now you don't have to worry about signs and so, because there's a plus sign here. When there is a minus sign, like in this case, you got to do something. But here, no problem. So now you take out what? M? This is an M, right? Take out m, you get x minus y. Here you take out n, which is x minus y in the bracket. Because these two are common, you get x minus y times m plus n. Right? Same answer. Same answer. It's just the arrangement, right? Just the arrangement. It's just the arrangement. So that was a tricky one, huh? That was a tricky one. We will take up back factorization a little later when we tackle quadratic equations, right? In the meantime, make use of the notes. Try some of the questions. You're not certain about the answer, you can always use AI to check your answer. I could give you the answers too, or if you have a textbook like this, what is it? What is it? Mathematics, a complete course for CXC by Raymond Tulsi. This is the volume 1. That's where I draw all the notes from. Good. So we'll pause there for the evening. It's not